Well, if we've determined already that our line is linear, we are going to have lots of options or lots of ways that we can graph our line. Okay, so in the previous section we found that if I solved, I found that I could create a table of solutions, right, for this equation that's down here, 2x plus y equals 1. I found that I could I could show a table of values that are the solutions to this particular linear equation. And we're going to use that, it's called the table method, to plot points and graph that on our Cartesian coordinate over here. In other words, we're going to take what we've learned in the last section and we're going to represent it as a picture now. Now you only have to have 3 points to make a line. I suggest you make 3. That way, in case something happens in the middle of your line, you have three good points. So it's a good idea to always have 3 points. I always choose a negative value. I choose 0 as one of my values because it makes my algebra easy, and then I choose a positive value. So I have the negative side, a 0, and the positive side represented in my x's. And I generally choose 2 as my negative and positive because those are they're getting me a little bit further away from the origin as opposed to like a 1. So let's plug in -2 into our equation, find the y value, and create a set of ordered pairs that we're going to then plot. Alright, so if 2x plus y equals 1 is my equation, I'm going to say 2 times -2 plus y is equal to 1. So therefore, -4 plus y equals 1, and y would be equal to, if I add 4 to both sides, y is equal to 5. So let's put a 5 over here. The next value I'm choosing is 0. So I plug in 0 for x. 2 times 0 plus y equals 1. That's gone, so y is equal to 1. See how easy that is? I love it when I choose 0. Okay, and now let's choose +2. So I take 2, plug it in for x plus y equals 1, 4 plus y equals 1, y equals, I'm going to subtract 4 from both sides, y is equal to -3. So let's put a -3 over here. Now remember, these numbers right here are the ordered pair, -2, 5, 0, 1, and 2, -3. They form the points that I'm now going to graph. So if I graph the first one, -2, 5, remember the -2 is the x value and 5 is the y, so I come up here and put a dot up there. The next point is at 0, 1, over 0, up 1, because we always do x first. And the last point is 2, -3, so I go over x to 2, down 1, 2, 3. Here is my 3. Now let me see if I can draw a line here. I want to connect these points using a line, and that's pretty close right there. Okay, notice I chose a line that had arrows on both ends because if you'll recall, there are more than just 3 points here that caused this equation to be true. And what this shows, this is like a picture showing us that any point that I find on this line, I could choose any point on this line, plug in the x and y value of that point into this equation, and it makes the left equal the right. If I were to pick a point out here and plug that into my equation, I would find that the left did not equal the right and therefore is not a solution. So what my line tells me is that any number that lies, or any set of any ordered pair that lies on this line, when I plug it into this equation, it makes the left equal the right. And if it's not on this line, then it's not going to make the left equal the right.